This is a problem from your lab assignment, section 3.2. They want us to differentiate this function, and this function looks like it's a product of two functions. It's 1 over y squared minus 4 over y to the fourth times y plus 6y cubed, and this is a function of y. So y is our independent variable, and we look like we're going to take the derivative with respect to y. So because it's a product, we will use a product rule, and the product rule says that we're going to take the derivative of the first function, multiply it by the second function, and then we'll take the first function and multiply that by the derivative of the second function. So we will rewrite the first term so that it's something that we can easily take the derivative of. We have a y squared in the denominator, which brings us to a y to the negative 2 in the numerator. And then we have a minus 4 that remains the same, and then we have a y to the fourth in the denominator, which means it'll look like negative 4 in the numerator. So now we're just going to use powers. The derivative of the first term is going to be the derivative of 1 over y squared, which is the derivative of y to the negative 2. So that negative 2 comes down, y to the, now here we have to be careful, it's minus 2 minus 1. So we're subtracting 1, and we're going to get negative 3. And then for the second term, we have minus 4 y to the negative 4. So the minus 4 and the power of negative 4 can get multiplied together, and that will become a plus, and then 4 times 4 is 16. Again, be careful with the power. We have minus 4 power. Minus 4 minus 1 is going to be minus 5. Now once you have that, the derivative of the second term is fairly simple. The derivative of y with respect to y is going to be 1. And then we have 6 and 3. So 6 times 3 is 18. So we'll put 18 here. And then this is y raised to the, subtract 1 to the power. That's 3 minus 1 is going to be 2. So now that we have the first term, the derivative of the first term, derivative of the second term, using the product rule, it says we want to take the derivative of the first term. We found the derivative of the first term over here, so it kind of got all strung out, but if you were writing this down, it might be good to have it written down on paper so that you just copy things that look like they're not too strung up. Anyways, they just want the derivative of the first term here. It looks like they just want the minus 2, and then the y raised to the minus 3 power, and then there's a plus 16 y to the negative 5th power, which is something that they have here already. So that's the derivative of the first term times the second, and here's the first term again. Now we want to take the derivative of the second, which we found, and so we'll just rewrite that. 1 is already there, plus, and so we just have to type in 18y to the second power. After expanding the parentheses and simplifying, we can conclude the derivative as follows. Okay, so I think they want us to simplify a little bit. Let's take our time with that. Let's write it all out. Minus 2y to the negative 3 power plus 16y to the negative 5th power times y plus 6y to the third. So that's the first part, and then we want to add on to that the y to the negative 2 power, I guess that's a minus, 4y to the negative 4 power, and then we have 1 plus 18y squared. So let's take a look at this and be really careful with foiling things out. let's see, when we multiply this, this is going to be, it'll be -2. This is y to the -3 times y, so that's -3 plus 1. We're adding the powers, so it looks like it's going to be y to the -2 power plus, and then we'll do the same thing with the 16 and the y, so that would be 16y to the -4 power, because we're adding 1 to -5, and so that's the first factor being multiplied by y. And now let's take that same factor and multiply it times -6 x, or +6 y to the third. So the next term here would be -2 y to the -3 and 6 y, so that's going to be a -12, and then y to the -3 times y to the third is just going to be y to the 0, which is 1. And then the next term is going to be the 16 times 6. So 16 times 6 is 96, and that's a positive 96y, and then the power is going to be -5 plus 3, so that's -2. So that's a -2 power. So that's the first term right here. Now let's take a look at the second term and multiply that. So when we multiply this, we're going to get, looks like it's just going to be y to the -2 as the first term, minus 4y to the -4. That's our second term. So that's the first factor being multiplied by 1, and now we're going to multiply everything by 18y squared. So that's going to be 18, and again the y's match up, so it's going to be 18, oops, let's put a plus, 18y to the 0 power, or just 1, and then we have 18 times 4, that would be 4, 3, 72, and negative, so that would be a minus 72, and then the power is going to be y to the, it's -4 plus 2, so that's going to be -2. That's a -2 power. Okay, so now we want to add this, the result that we got here, and then we're going to add this to it, the result that we just got. Alright, let's alright, so now we're going to look for like terms, if we have any. It looks like -2 power, -2 power, so this has a factor of coefficient of -2 plus 1. Anything else? And let's boldface that. Boldface this, also -2, this is -2, this is -2, so there's a few -2 powers here. So what do we have? We're going to add -2 plus 96, so that's positive 94, positive 94 plus 1, that's 95, 95 minus 72, that's going to be 23, 23y to the -2 power. And then now we have some stuff that's to the -4 power. Let's put a color on this to make it look a little bit different. We have -4, that's 16. We have this thing to the -4, and that's it. So 16 minus 4 is 12. So that's a positive 12y to the -4 power. And then the rest are constants. We have a 12, -12, and 18. So we subtract, we're going to get a positive 6. Alright, so all that hard work simplifying, we're going to get a 23y to the -2nd power. plus 12y to the negative fourth power, and then we have a plus 6 at the end. Okay, so hopefully we simplified correctly, and if we did, then we would have gotten that whole thing correct. Their answer looks like got rewritten so that the negative powers came down in the denominator, so I think that's fine. So that's it. So the hardest part here really was the simplifying, and a lot of times you want to simplify to make sure that you got the correct answer if you're matching with the back of the book, or you simplify so that when you take the derivative again, in case you have to, you'll have an easier function to take the derivative of instead of something really complicated like what we had here in the beginning. All right, so hopefully that helps.